Okay, but now we're going to be looking at how we can the methods that scientists use to um, look at past climates. There's numerous ways to do this. So the first one we'll talk about is carbon dating, and then we'll look at tree rings. So basically, I'm not going to get into the science of this. You can read this in the textbook, but when elements decompose, they have what they call a half-life, the time it takes for half of the sample to undergo radioactive decay, and you can measure that. And so you know how many years that is. So you can measure the amount of half-lives the element has decayed when you find fossils and so forth, and that will allow you then to figure out how many years ago or how many years old your sample is. And this is this is from your book, but it's, so here's the carbon-14 that's the remaining, that's the percentage, and here's the number of half-lives. So each half-life is, about 5,700 years. So, 2 would be, double that, and 3 would be, 3 times that. So, based on the amount of carbon that the percentage that's remaining, gives you some idea then of how old your sample is. And then you can use that then. You can say, okay, we found out the oxygen levels were this high, 1,500 years ago or 15,000 years ago, based on this carbon dating. Another fairly easy way to do this that we can do today, even just doing it in labs and stuff, is the tree rings, the annual growth bands found in trees. And the wider the rings, the better the growing conditions were. So here's just an example, a core sample here. So notice here where the rings are wider, that means the growing conditions were good. So that usually means, the weather was good, there was plenty of moisture. Where it's narrower, the conditions were harsher. So it might have either been a drought or it might have been very, very cold temperatures. That gives you some idea. And each ring is basically a year. You can take cores from lake sediments. That's a very common way to do that, and many geology programs do that. You can look at the limestone formations in caves, and do a cross section of those. And again, you can see the growth bands there, kind of the same thing. So what trends do we know from this? Well, we know that the Pleistocene began about 2.5 million years ago, and that the last glacial period lasted from about 110,000 years ago to about almost 12,000 years ago, which was the last glacial maximum. And ever since then, we've been warming up. So here's the climates for the last 20,000 years. So here was the last glacial maximum, the extent of the last ice age. So the glaciers had covered up Canada and reached down into the northern part of the United States and covered much of Europe. Then we started getting warmer. And notice there's this big temperature increase right here. Then it goes back down very abruptly. We call this the Younger Dryas. This was about maybe 12,000 years ago. Then temperatures go back up again. And we continue on. So it's been pretty, there's up and downs, of course, but it's been within this very narrow band. And here's snow accumulation. So it's been within this narrow band ever since about maybe 12,000 years ago. Now, what we're interested in is the short-term climate trends. About 14,000 years ago, the temperatures abruptly increased for several thousand years. Then they dropped again very abruptly. We call this then in the that was the driest period, so warmer and younger driest period. So we got one warm period and the cold period. Then we had this warm spell that they called the medieval climate anomaly. Lasted about 400 years, from about 800 to 1200, where it was pretty mild, but it affected the North Atlantic, where the ocean temperatures warmed up in some places and cooled down in others. But what a lot of people think is that it lessened the amount of ice in the North Atlantic, and that allowed the Vikings to travel across from Europe across to Greenland and even into North America. then once they'd settled there, but then when that period was over, temperatures started to decline again and ice formed and the Vikings couldn't get back and nobody could come join them, so the settlements died out. Then the other one that usually gets a lot of attention is what we call the Little Ice Age. From about 1250 through 1850, temperatures cooled globally, and most people think this was from volcanic activity and changes in what we call the global oscillation periods in the ocean. Ever since then, about 1850, temperatures have been warming, and most people think that's because of the industrial activity that's putting pollutants and into the air. Now, on your module, the weekly chapter module, there's a couple of videos that you should watch, one on supervolcanoes and one on volcanoes and climate, that'll give you some idea of how volcanoes can contribute to these warming trends. Okay, so let's stop here and then we'll do solar variability in the next one.